The last problem is an application problem, and it's going to be a punted football. So here's the idea. Someone's standing right here, they're kicking a football, and we want to answer various questions about the path of the football. And here's the equation that we use. The height is related to negative 0.01x squared plus 1.18x plus 2. So the first thing we want to find is what is the maximum height of the punt? In other words, I want to know how high that is going to be. And how do we find the maximum height? Well, that's the vertex. Now, when I look at this one, I see this 0.01 and this 1.18. I don't want to have to complete the square with all these decimals. So this is one of the examples where it's probably easiest just to use the formula that gives you the equation, or the formula that gives you the vertex from your standard form equation instead of trying to convert. So maximum height, we want to find the vertex, and specifically the y value of the vertex. So the x value of the vertex is negative b over 2a. So negative 1.18 over 2 times negative 0.01. And if we solve that out, we should get 59. So the x value is 59. We then want the y value. So f of x is equal to negative 0.01 times 59 squared plus 1.18 times 59 plus 2, which is going to be 36.81. So the vertex is 59 and then 36.81. So specifically the height of the punt, its maximum height, is going to be 36.81 feet. The second question, the nearest defender is 5 feet horizontally from the point of impact. How high must the player reach to block the punt? So what I'm curious about is if we've got someone standing 5 feet away, and here's the other person, how high up is the ball going to be? So with this one, I don't need to figure out how far horizontally I need to go. I can just plug the value straight in because I'm 5 feet. That's my x movement. How far am I? So I can just go right here. F of 5 is equal to negative 0.01, 5 squared, plus 1.18 times 5 plus 2, which is going to be 7.65 feet. So the defender must reach 7.65 feet into the air to tip the ball. As the ball, when it's only 5 feet away on the parabola path, is going to be 7.65 feet high. The third question, how far downfield has the ball traveled when it reached its maximum height? Well, we know that from the vertex, which has an x-coordinate of 59. It's 59 feet away from the punter when he kicks it, the horizontal distance. And then how far downfield has the ball traveled when it reaches the height of 6 feet? Well, for this one, we know that the equation, our height is negative 0.01 x squared plus 1.18 x plus 2. And we know the height is going to be equal to 6. So if I wanted to move this 6 to the other side, so it's equal to 0 and use quadratic formula, I could do that. But for the point of this, I'm just going to plug this into my calculator. And let's see what we've got. So we'll go here, negative 0.01 x squared plus 1.18 x plus 2. And that looks like a straight line. It's only because I'm zoomed in so much. If I were to zoom out just a little bit, I might get more of a parabola shape. And as I continue to zoom out, you can see there is the path that the ball is going to take. Now I can see how far downfield has the ball traveled when it reaches the height of 6 feet. I'm interested in knowing when is the value equal to 6. So I want to create some sort of intersect equation where this piece here is y1, this piece is y2. I really can't see that too well. So I'm going to zoom back in, and I know somewhere over here I'm going to have an intersection. And there's my first intersection point. So second calc, intersect. And I can see right here, when I've got the height of 6, my x value is 3.493. Now I also know on the other side that the ball has to come back down. So how far does the ball travel the second time? So we'll zoom out a little bit, and then we'll zoom back in. Actually, let's do a zoom box. You know your zoom box? Zoom box allows you to create a box. You draw a box on your screen when you hit enter for where you want to zoom into. So there's the part that I want to zoom into. There's my line. And if I do second calc and do intersect, where do these two lines intersect? Well, it's going to be at 114.507 feet. So how far downfield has the ball traveled when it reaches a height of 6 feet? There's two different values that you've got. One is it's coming up and one is it's coming back down. And you said you could have solved this using quadratic equation. You could have completed the square and solved. But this one I thought it'd be good to use a graphical perspective on the calculator.